Thanks for everyone who attending our Tech Talk today. And let me share my screen. So let's discuss what drones can do for agriculture and agri-insurance. Oh, there is a small technical issue. I'm sharing right now. Let me stop on our today's agenda very briefly. Because of the time limit we have, very briefly we'll touch the main farmers and insurers challenges which drones can help with. Then we'll take a quick look at the technical options available on the market, from the most affordable to the most expensive, and make a drone types overview from the technical design perspective. So which typical tasks in farming drones can solve? First of all, it's soil and field analysis. Drones can be useful at the start of the crop cycle. They produce precise 3D maps for early soil analysis, useful in planning seed planting patterns. You'll be able to see if there are any issues with the soil quality, with nutrient management, or soil dead zones. And after planting, drone-driven soil analysis provides data for irrigation and nitrogen level management. Planting. There are some cases of using drones for seed planting. These systems shoot pods with seeds and all required nutrients into the soil. Commercially available drones have limited payload, usually around 50-55 pounds, and typically used for either trees planting or maybe for spot replanting of damaged crop. And crop spraying and spot spraying. Vehicles are slow and sometimes have limited access to the spots. Airplanes are costly and inaccurate, and spot spraying of crops used to be incredibly difficult. If you had an issue with weeds or a certain crop, the entire acreage would have to be sprayed. With approval from the Federal Aviation Administration, drones can be equipped with large reservoirs, which can be filled with fertilizers, herbicides, pesticides, and using drones for crop spraying is much safer and cost-effective. Drones can even be operated completely autonomously and programmed to run on specific schedules and roads. So with spot spraying afforded by drones, this same task can be accomplished in less time, less money, and at reduced environmental cost. Crop mapping and surveying. One of the biggest advantages of using drone technology is the ease and effectiveness of large-scale crop and acreage monitoring. Satellites and plane imagery are expensive, lacking precision, and usually cannot be scheduled for regular use. With drones, you can not only obtain real-time footage, but also time-based animation, which can eliminate crop progression in real time. So instead of using some empirical guess, make your decisions based on the real-time data. And you're able to collect plenty of information like overall crop and plant health, land distribution based on crop type, current crop life cycle, detailed GPS images, detailed GPS maps of current crop area. And you can also not only use standard RGB cameras, but also near infrared, thermal, multispectral, and interpret those data to maximize land and resource usage and help farmers to better determine crop planting locations. Then irrigation monitoring. Drones that are equipped with thermal cameras can help to spot irrigation issues or areas that are receiving too little or excessive moisture. And the last but not least, real-time livestock monitoring. Drones, again equipped with thermal imaging cameras, can also be used to quickly check in on herd and to see if there are any injured or missing livestock, see livestock who are given birth, and monitor if there are any predators around. Now, regarding the agri-insurance, So typically it includes two phases. It's a pre-claim phase, which affects insurance premium amount and other expenses, and post-claim, which actually affects payouts. During the pre-claim, we can use drones for increasing price and accuracy and risk reduction. So assessing aside from the sky allows for a more accurate risk profile, which in turn impacts the costs involved. Then monitor natural disasters. Drones can also be deployed to safely and quickly monitor areas under threat from natural disasters such as fire, floods, earthquakes, whatever, and prevent the claim rather than pay for it. If something happened, then using drones, we can provide a site inspection. Using drones offer a faster and safer and more cost-effective way to undertake site inspections and measure damaged areas, especially if doing so from ground compromises the safety of the inspection team. Claims decisions. The decisions-making process is made a great deal easier thanks to precise and high-quality imagery, which is also a more unbiased way because both adjuster and farmer operate the same comprehensive data. And of course, fraud prevention. Fraudulent claims amount to 30 or 32 billion each year. So drones can help counter these claims by capturing accurate information in a timely manner. Now the question is, do we need to pay a few dozens, hundreds for an expensive professional drone, or may choose a consumer drone for the fraction of that price? And to answer this question, let's start moving from the less expensive options and think what it can offer for the buck. So on the low end side, we have consumer drones, which are completely usable for manual visual monitoring or for automatic monitoring using waypoints, which you can set and schedule this drone to run automatically. It has a flight range of 30 to 40 minutes, which means 15 to 20 miles of distance. The communication range is obviously less. It's only 5 to 5.5 miles. But the main disadvantage, they're not weather sealed. Usually they can withstand wet conditions, but even after flying in a rain shower, they'll stay working with a high probability. Though, of course, under the heavy rain, it's better to extract the drone from emission as soon as possible. And this means that out of the box, you can use drone in manual, as I said, mode or automatic mode just for visual surveying and monitoring. By adding some specialized software for crop mapping or vegetation index monitoring, you can expand the usability of your drone. You can import your videos into third-party software and get the high-res 3D terrain models, measure the vegetation index. Of course, it's not that accurate as using near-infrared cameras, but it's still possible. But you can also buy a semi-pro version of the same consumer drone, or just upgrade the camera to the specialized camera like near-infrared or thermal or even multispectral, and it will add you ability to measure accurate vegetation index, which is really important for the determining of crop health. You can use it for livestock monitoring. You can use it for irrigation monitoring, and it's already plenty of useful applications, and you still use quite a cheap drone available on the market without any custom modifications to either hardware or software part. On the opposite side of the scale, there are professional drones. It's a specialized drones which usually also include a specialized software which allow finer control over the drone, more flexibility in flights planning and special processing. They may include multiple additional sensors, be able to carry heavy payloads, and be equipped with a specialized tool for probing, planting, or spraying. Best of them support easy tool replacement and reconfiguring of the drone for a specific task. Any additional tools, of course, come at separate price, and the final cost can rack it up easily. But the main advantage of these drones is that they are more robust. They they weather sealed and can better withstand any difficult weather conditions. Usually they're more reliable in terms of battery life, and for instance, they can be serviced with ease because of modular construction. A good alternative to the pro-grade drones is custom-built drones, which may start from 3,000 to 5,000, but upper price is limited by your imagination only. This option is the most flexible because you can deploy your own custom firmware tailored for your very needs. You can make the drone to fly autonomously, to patrol your field, and scanning for any issues, then swoop down and fly around any suspicious spot, even if it needs to navigate through the trees and other obstacles. And you can make any real-time integration you may need and easily integrate it to your existing infrastructure. But it's a whole bunch of work, and such a project can cost you a lot. And in such a case, the major part of the expenses will be not a hardware, but a software development. So you need to be careful in determining your actual needs. And first, always try to find the off-the-shelf solution. And only if there is no available, start thinking about making your custom one. But once being developed, the solution can be replicated multiple times without additional expenses. So it makes sense if you're going to scale up in the future and want to save some money comparing to buying the professional drones or get more flexibility. Now, a few words about types of drones available on the market. Probably the most known, which all of us can see around, are copters. The most common are quadcopters or hectocopters and octocopters, which fly like a helicopter using horizontally spinning rotary motors. But there are also fixed wing drones, which looks like and fly mostly like a regular plane. I didn't put the picture. Everyone knows how a regular aircraft looks like. So advantages and disadvantages. Fixed-wing drones have their advantages with approximately the same size and weight. They propose either better flight range or a higher payload, typically 2 times higher, 2 times better, which means they can either cover a larger area or carry more hardware. And this works great for many tasks, for crop mapping and vegetation index measurement for the 2D crops, and overall surveying, or maybe even crop spraying due to the higher payload. But on the other hand, it can't hover on the spot to do some precision work. Of course, it's not a large manned aircraft which flies, for instance, if we take spraying, the large manned aircraft can fly high and spray your field and field of your neighbor and some towns around there. The fixed-wing drones are much smaller and can be used with more precision, but a copter can be even more precise, and though it can carry less liquid, but it can use it much more efficiently. A fixed-wing drone can fly between the trees to estimate their status. It can plant seeds because that require much lower speed and better precision. And it doesn't allow to stop and take a closer look to some land spot for visual assessment of the damaged area, for instance. And the most important, it requires a special infrastructure to take off and land. So between those two, copter is a bit more versatile. Indeed, there are one more type of vertical takeoff and landing drones which combines advantages of both. There are drones which can take off and land vertically and fly like a fixed-wing aircraft, a lot of time. So there are two types of them: tail-seaters and quad planes. Tail-seaters look almost like a regular plane, but it takes off and lands in a vertical position, tail down, that's why the name. Then it turns into horizontal position and flies in normal plane. It looks like it's really good combination of fixed wing and copter, and it is. But honestly, this type of aircraft isn't as stable when hovering as a copter, and there is a certain difficulties with the mounting of the hardware. So it has certain trade-offs, but it's a good technical solution, though there is not many of the shelf solutions to choose from on the market. Quad planes use additional rotors for the vertical takeoff and landing, or use tilting ones. So in theory, they have all the advantages of both fixed wing and copters, but they're more technically complex than either fixed wing or copters, thus less reliable, heavy, and bulky. And then honestly, there is even less propositions on the market than for tail-seaters. Well, and maybe my final thoughts. Of course, someone may say that all the problems mentioned are exaggerated, as well as the effectiveness of the solution that drones propose. It is true, at some extent, drones aren't a silver bullet, and it's still an evolving technology, but everything is moving towards robotics and automation. So if you start integrating it into your process now, then we'll have a huge competitive advantage in a few years. And I believe investments into technologies are always good thing, if you only understand, of course, which of your business problems the technology solves. And in my presentation, I mostly touched the technical part of this topic, because ELEKS is a company who has experience in building custom drones for the large commercial aircraft assessments. But our next speaker, Casey Roberts, will perfectly complement the same area by giving an overlook from the insurance professional standpoint, I believe. So that's it from my side. Thank you.